The film you're about to see has no characters, it has no people. It is a film to describe to you and explain visually the effect of cymatic frequencies on texture, structure, water, oil. If you spare a little of your imagination as you watch this film as it runs, you will see many things that answer many questions. You will see living forms, living amoeba, almost animal-like creatures. You will see continents being formed, the earth itself coming into existence, explosions, eruptions, atomic explosions and bombs. You can see all this and watch it before your eyes, but everything owes its existence solely and completely to sound. Sound is the factor which holds it together. Sound is the basis of form and shape. In the beginning was the Word, and the Word was God. We are told that this is how the worlds began and how creation took shape. If we put that into the modern idiom and say that into the great voids of space came a sound and matter took shape. Please watch carefully.
We can also use different shapes of plate. Here we have a triangular plate with a crystal attached to its underside and produce a sonorous figure. We change to a higher note and see a rather more complicated figure. This more elaborate figure, likewise on a steel plate, is also produced by vibration. The exciting crystal is attached to the upper corner of the plate. We use sand and lycopodium. The lycopodium moves to the center of the fields and takes up circular shapes. The sand forms the lines. Each material has its own special way of behaving. Lycopodium alone, a sonorous figure, transition to a mobile flowing phase, and back again to the figure. The sonorous figures represent stationary waves. But now we can also observe moving waves. Here the sand is flowing in a current. When the wavelengths are short, these currents produce a rotary effect. Areas become defined in which the particles are actually rotating. Now we produce two notes with frequencies which are so related as to cause a beat. The note seems to throb, and by using the method we have chosen, this phenomenon of beat or interference can be rendered visible. The figure sways to and fro, the figure pulsates. The picture has changed completely. Now we are exciting fluids. Under vibration, a layer of turpentine forms a regular lattice work. In vibrating glycerin, we see continuous waves which form the queerest figures. And yet, the extraordinary things we see here are simply and solely the effect of vibration. Here is a sonorous figure shown in a fluid. There are some wave fields where there was nothing before. Where there was previously sand, now there is nothing to be seen. The dynamic phase has become the static phase. Wave fields which make the vibratory process in the plate indirectly visible. Here again, interference can be demonstrated. All these wave fields pulsate. Interference becomes visible. A fluid colored black is dripped into a transparent fluid. Vibration now gives rise to curious eddy formations. It is always a pair of eddies that is created. One pair after another is generated so that we finish up with a whole series of such pairs of eddies in a symmetrical arrangement. formation of these eddies by vibration is particularly significant because it is eddies of this kind which are specifically formed in the cochlea of our ears whenever we hear sounds. That is to say, they are not ordinary eddies as defined in rheology, but vibratory eddies, with the members of each pair turning in opposite directions. A plastic substance. A plasticizable substance is always shaped into a ball by the wave trains of the vibrating membrane. The masses are jiggled round, but gradually proper spherical shapes are formed, created by nothing more than the vibratory process. The human voice can also be made visible with a simple apparatus. The various vowels show typical characteristics depending on the nature of their sound. We can see the spectrum, as it were, of the sounds. A sequence of sung notes comes out as a sequence of vibratory patterns. We can see a melody. Music can also be made visible. The same membrane that emits the music can also make its vibratory processes visible through the medium of a fluid. Here we have the last 89 bars of the first movement of Mozart's Jupiter Symphony. We can see Mozart while we hear him. lycopodium powder, the spores of the club moss, reveals a number of quite remarkable phenomena when made to vibrate. Circular shapes appear, but these are in a state of continuous upheaval. The particles are pushed outwards from the center and inwards again from the outside, and at the same time they pulsate. We can recognize the various patterns of the vibratory fields. They move to and fro, unite, and separate again according to the vibratory state of the surface formed by the membrane. And we can, as it were, move over a landscape which is in a state of vibration. If we intensify the note, if we produce a crescendo for the ear, the masses are hurled outwards. We see fountains, eruptions, explosions almost. But invariably, the particles return to the center, so that here again, even under these violently dynamic conditions, we find there is circulation. Here, a quick glance at a phenomenon with no vibration. Two liquids which spread by surface tension. No vibration is involved, but this phenomenon also progresses periodically, expressing the ubiquitous law of periodicity. Now we excite the surface on which the liquids are running. An entirely different picture is produced. It is even possible to make out a circular formation. Now there is vibration, but then the vibration slowly ceases, and again we see a phenomenon without vibration, the regular pulsation of these spreading masses of fluid. The behavior of iron filings when subjected simultaneously to a magnetic field and emission shows that adhesion to the surface is substantially reduced. The magnetic lines of the force round the poles show up with exceptional clarity. If we cluster the magnetic lines together, we can see the effect on the patterns formed. If we thin out the lines of force, the phenomenon spreads out. Because of the reduced adhesion, the particles of iron have certain degrees of freedom. They can move, fall into line, form figures, and almost dance, but only in obedience to the vibration imposed. Even these serpent-like formations are produced simply and solely by vibration over areas of the vibrating membrane representing movement processes. All materials and substances and the various states of aggregation behave in characteristic ways under the effect of vibration, or we can say that their behavior is specific. Here is a pulp. Here again, round shapes are formed, and circulation is set in motion, but in the opposite direction to that observed with lycopodium. There is a definite ripple effect caused by the wave trains in the vibrating membrane, a rich field of effects due to vibration. They join together, separate, and pulsate. If we intensify the vibration, equivalent to a crescendo for the ear, the masses are thrown into ever greater agitation. They are ejected, spikes are thrust up, there are eruptions, protuberances appear, and all due to the dynamics of vibration. A whole landscape opens before us. The note we hear is strong enough to originate all this turbulence, this impressive display. And, to end with, here, by way of contrast, is a sonorous figure, a static figure instead of a dynamic one, representing the opposite pole in the vast range of phenomena that make up the world of vibration.